My name is Thomas Watson, as Ian just said. I'm Watson on GitHub, so if you want to see all the weird stuff I'm doing there, you can find me there. And I wasn't that quick getting my Twitter handle, so I had to improvise a little bit. Anyways, my day job is working for this company called Upbeat, which does application performance monitoring in the cloud. And I'm responsible for the node stack. So I deal with performance and trying to figure out how to measure performance and making things quicker almost every day on systems that I don't control, which is pretty funny. So the title of my talk, it goes to 11. So what does that mean? Many people have asked me that. And you could also rephrase it as how to write code that writes code. Or maybe you should say when to write code that writes code, because there are definitely a lot of times, most of the times, where you shouldn't do it. So why? Why would you want to do that in the first place? The answer is in one simple word: performance, of course. But as I said before, writing code that writes code is extremely hard. And there's a lot of pitfalls. And it involves, well, it doesn't necessarily involve using eval, but it involves using the new function generator. And we've all been told, ever since we started doing JavaScript, never use eval, and never evaluate a string as source code. Which is why it's a pretty risky thing to do, but if you need the performance, it can be an interesting approach. So what I mean, when is this an approach that you should consider? So it's an approach you should consider if you have a function that takes some kind of seed thing and some data and the seed is every time you give it the same seed, it performs the same operation on the data. And the seed is, I'm not talking crypto here, though I guess crypto it could be used there as well. But it could be anything where you want to operate on some data based on something else. What you should do instead, at least if the seed doesn't change that often, is you should do this, of course. You should first have one function that takes a seed that gives you a generator function that you can then feed the data, and then you can pre-compile the stuff from the seed. You can pre-compile that in the second function, so you don't have to do that over and over again. And that is basically where you get the speed, and that's my talk. Anyways, so this is an oversimplified example. You have some function that does some math, for example, takes two arguments, a and b, and a in this example is our seed, and it does something with a first, and then it adds b to it. So we've all learned, this is JavaScript, we love closures, right? We all learned that we can do something like this. So this is like the functional approach of doing this. So we prepare the math, and then we closure over the a argument, and then we return a function, the do math function, that only takes the b argument, and then we just reuse the a all the time. So what I'm talking about here is, you could even go a step further, is that you can prepare basically some source code. You can do that function up there, and this, as I said, is an oversimplified example. So in these cases, it might not make a big difference, but there are cases where this makes a big difference. So you basically make the string a plus b, and a is now replaced by the actual value of a, and then you return that. And then the new function is for you guys who have been using eval all the time, you should be using new function. You should not use eval anyway. So the last argument in the new function is the source that you want. It generates a function for you. I hope that's obvious. But then any arguments coming before that is going to be available as variables inside the function, given the name that you're giving it. So now when I'm returning new function b and source, it generates a function for me that takes one argument, and it will be called b. So it's available inside as b when I'm running the function. So where do we see this? Already we see this actually using regular expressions. We use that all the time. We have a regular expression generator, and then we can always call test on the same regular expressions. So actually what's going on behind the scenes is kind of that it's taking this string that we're giving it, and it's generating a hyper-optimized function, some code that will actually pass anything I pass into it and figure out does it match the regular expression. So, quick disclaimer. I didn't come up with this, of course. Any of you guys are comic strip fans? Comic strip % fans? I'm in England. Nobody? Oh, there's one. That's awesome. So I didn't come up with this. I was inspired to do this talk because a friend of mine and I, Matthias, we were talking about how to validate JSON. And there is a schema, there's a standard called JSON schema that you can use to validate JSON. So if you have a JSON API for your app or whatever, you need to make sure that whatever the client sends you is conformant with your API, right? And all the JSON validators, the JSON schema validators out there were really slow. So using this technique, he made this thing called isMyJSONValid. And being Node, I mean, we want to have like really nice names. So it's really simple. Basically, you require the module, and then you give it. You have this generator function that you can call with the schema, and now that returns another function that you can then call with the JSON that you actually want to get validated. So all the heavy lifting about figuring out how to pass the schema happens once, and then every time somebody calls your endpoint where you need the validation, you only need to do this. So yeah, the computation of the schema only happens once. And I couldn't find, I think this was in 2004, and I couldn't find the benchmarks we made back then, but this is from a year later, and so the competition had a little bit of time to catch up. So isMyJSONValid was at this point, a year later, still 3 times faster in validating JSON than the closest competitor, and it was even better back when he made it. So where do you want to use this sort of technique? I already said schema validation, but it could also be templating engines and stuff like that. So without further ado, let's dive in and write our own query language interpreter. There's already a lot of query languages out there. We have in MongoDB, we have a JSON kind of query language where you can query for a document with the property foo that has to be greater than 42 or less than 100. We had the JSON schema, as we saw before, where you can say that we want to make sure that the object have a property called a property, and it has to be a string. So the language that we're going to make today is basically going to have like 4 different operators. An equal operator, greater than, less than, and then a negated version of any of those. Coding time. Whoa. So, and then I should probably just unmirror my screen here. Where's my mouse? There it is. Because otherwise I'm gonna, my neck is gonna hurt. Excuse me 1 second. There we go. This is much better. So I have a simple example here, and this is the code prior to making any optimizations. Before I show you this, I've written a small benchmarking thing, and benchmarking is hard. So bear over with me. But basically, we load an interpreter. Then we require some data, so we have some data to play with. Then we try to make a query using this query language that we just invented. And then we try to run it like a bunch of times, trying to query the data. And then we just output like how fast we were, right? So there's a simple scenario where we do the closure thing. Can you see it's the bottom here? So we take the query, that returns a function that takes a document, and that basically queries the data based on the query. And it's really simple. It basically just loops over all the keys in the query, and for each of them, make sure that the document that there is a document that matches, and returns that. And here's the actual property matcher. So I'm basically just having these two large objects where I'm like checking if it's an equality, then I have to do this. If it's less than, I have to do that, and et cetera, and et cetera, et cetera. So this all happens runtime. So if I run this through the bench thing, so bench and simple, we'll see that we can like select 668 matches per millisecond. Still pretty fast, right? So there's also, so what we could do if we knew this up front, like exactly what kind of thing let me rephrase that. We can compile the query instead. So we still get the query, and then we compile the query and we return a match. And the match, if you go up to compile query, is it's a function that tested everything in the query matches, and that function takes the document that we want to test. So basically, I replaced in this compile property here, I replaced everything with functions that we can then call. But notice that we are still entering, like we're still operating on the query like in runtime. So we're still like doing prop.up, with up is the equal, less than, greater than, etc. But it's actually faster. So if we take the functional post, so now we can do like this already a great improvement, 11,000 matches per millisecond. But of course, we need to do it this crazy way. So what I'm doing now is basically doing the same thing as before. I still have the same kind of, go back to down to the bottom here. I'm still compiling the query, but I'm now using the new function thing. So the compiled query will now return a string, and I'm now generating a function that has evaluated that string and takes the document as the first argument. And then in here, I still have to runtime when I'm checking. I still have to say have the document that I haven't passed in, and then the property on the document that I want to check for, in this case, equality. But now I can just have the value here of whatever the schema tells me that, or the query in this case tells me that I want to check for. So if we go into the bench thing here, you can see we want to test the city has to equal London. We need to test that the population is less than 10. I don't know, it should probably be greater than. Awesome, of course. And some stuff property should not be equal to data. So all that is now inlined into a simple equality operation. So I don't have to check that every time. I just take the value that is in the query. And if I try to run this, so now 35,000 checks, matches per millisecond. So this is, of course, a great improvement from the 668. And if you want to see how this looks, so basically, what is this match actually, this string that we are generating actually look like? So it's generating a function that takes one argument, the document, and then it's just inlining all the stuff in the query, like London, less than 10, also has to be true, and the stuff cannot be equal to data. So this is, of course, way, way, way quicker. But we don't want to write this by hand because we want to have our query to be able to change our query all the time. So that's why generating this using one of these things is really, really neat. So because generating code is insanely hard, and when I say hard, I mean like you can burn yourself, of course. There's a few modules that can help you out. So for example, generate object property. As we saw before here, we had to say, okay, we need to access the doc. You need to access the doc object here, and then we need to like access the property on the doc object, and then you need to close that. And it's like it's really complicated to write this, and you can quickly like mess up something. So, oops, where did my slides go? There. So what we can do instead, we can use this generate object property, which basically takes the object and the property as arguments, and it will then generate the dot notation if that's possible, or the square bracket notation if it contains a character that means that we can't use the dot notation. So that makes it a lot simpler. Likewise, there's always also a thing called generate function, a module called generate function, which makes all this code you saw before way, way easier to write, and also produces code in the end that is easy to debug. Because imagine like having this one long string of code, how do you debug that if you make an error in it? So you require the generate function, and that returns this chainable function that you can call again and again and again. And it looks for the opening curly braces and the closing curly braces, and opening square brackets and closing square brackets, and automatically adds indentation to every line. So every time you call, so we call it here, my mouse somewhere, it's not anywhere. Anyway, so we have the function add n, then we close, and then we have a new line, return n plus d, and it even supports format strings, but that actually makes sure that there is actually a nice new line in the code that's generated, and it also makes sure that it's indented properly. So by having the support for format strings, it means that we don't get into the trouble of, let's say we expect a integer, but somebody, instead of writing the number 42, they wrote console log something, and we basically, instead of having SQL injection, we have code injection. This is a way to help you protect a little bit against that, which is, of course, really, really nice. So that's it. Thank you.
Thank you, Thomas. All right.